All right, we're going to take a look at more of how graphs represent solutions. Now, what I want to go over today is just writing in the table for exponential functions. So the first problem we're going to take a look at is y equals x, 7 to the power of x. Now, we're still going to be using the same x values, -2, -1, 0, 1, and 2, as we covered in the first unit. We're just going to do some more practice with filling in this particular table tonight. So when we're working with these values, we're going to be substituting -2, -1, 0, 1, and 2 into the equation. Now, tonight and what we're going to do in class tomorrow, we're not going to be using a calculator, so we're going to get that hand computation down. So let's start at the middle of our table, and we'll go down and go back to the negative exponents. So when x is 0, we get y equals 7 to the power of 0. Now, any value other than 1 raised to the power of 0 is going to be 1. So when x is 1, y is 1. And when x is 0, y is 0. We're going to substitute 1 in for y, or x. So we get y equals 7 to the power of 1, which equals 7. 7 times itself just once is 7. And then when our x value is 2, we get y equals 7 to the power of 2, which you can think of as x times x, or 7 times 7, which is 49. All right, the reason why I want to go over those is I want to take a look at when we have negative exponents, just to go over that concept a little bit more in detail. So when we have an x value of -1, we get y equals 7 to the power of -1. When you have a negative exponent, we can rewrite this expression as 1 over 7 to the power of +1. The same goes true when we have y equals 7 to the power of -2. We can rewrite that expression as 1 over 7 to the power of 2. So we're using the definition of exponents. If we have a to the power of -n, we can rewrite that expression as 1 over a to the power of +n. So when x is -1, we get 1 over 7. And then when x is -2, we get 1 over 49. So that will be our table for y equals 7 to the power of x. All right, the next problem that we're going to be taking a look at is y equals 1/5 to the power of x. Now, once again, we're going to be using the same x values, -2, -1, 0, 1, and 2. The difference here is going to be in some of the computations due to the fact that we have a fraction. All right, so let's take a look when x is 0. So when x is 0, we get y equals 1/5 to the power of 0. Once again, since 1/5 is not 0, anything raised to the power of 0 is going to be 1. So that does not change. All right, then let's do y equals 1/5 to the power of 1. Here we're using our quotient of power properties, which states if you have any value, so if you have m over n raised to the power of a, that equals m raised to the power of a and n raised to the power of a. So we raise both the numerator and denominator to that power being expressed, and here it's 1. So we'll be raising 1 to the power of 1 over 5 to the power of 1, which equals 1/5. And then when x is 2, we get y equals 1/5 to the power of 2, which once again will be 1 squared over 5 squared. 1 squared, 1 raised to any power is 1. 5 squared is 25. So we have 1 over 25. All right, now we're going to take a look at with those negative exponents. So the negative exponents is going to be a combination of what we talked about in problem 1 and also what we just covered in problem 2 using the quotient of power property. So y equals 1/5 raised to the power of -2. So here we're raising both the numerator to the power of -2 and the denominator to the power of -2. Now, in using that definition of negative exponents that we looked at in example 1, we can rewrite this expression as 5 squared over 1 squared, which 5 squared is is 25. 1 squared is 1. So when x is negative 2, our y value is going to be 25. And then when x is negative 1, we get y equals 1/5 raised to the power negative 1, which equals 1 raised to the power negative 1 over 5 raised to the power negative 1. Once again, using our rule of negative exponents, we can rewrite this expression as 5 to the power of 1 over 1 to the power of 1. So this will equal 5 over 1, so our y value is 5. So that's what happens when we have a fraction. And this, we'll look at the graphs a little bit more later on, but we've talked about this in Unit 1. This will be a decay. All right. Third problem. We are looking at y equals 2, open parentheses, 3, close parentheses, raised to the value of x. Once again, using our same x values for this function, I'm going to start off with 0. So y equals 2 times 3 to the power of 0. Keep in mind PEMDAS, we do parentheses, everything's simplified inside the parentheses. Exponents, 3 to the power of 0 is 1. So we get 2 times 1, now we're moving to multiplication and division. So our y value is 2. All right, I want you to go ahead and finish up these. I'll be working them out and talking about them. Just check back to make sure you have the correct answers. So when x is 1, we get y equals 2 times 3 to the power of 1. So that equals 2 times 3, which equals 6. When x is 2, we get y equals 2 times 3 to the power of 2, which equals 2 times 9, which equals 18. And now we're looking at our negative exponents, and just to make sure we have enough room, I'm going to erase those. So when x is negative 2, we get y equals 2 times 3 to the power of negative 2, which equals 2. And this will be 1 over 9. So we have 2 times 1/9, which is 2/9. Keep in mind, think of 2 as over 1, and we multiply fractions, we multiply the numerators together. 2 times 1 is 2, 1 times 9 is 9. And when x is negative 1, we get y equals 2 times 3 raised to the power negative 1, which equal 2 times 1/3. 2 over 1, so that will equal 2/3. And that will be our table for y equals 2 times 3 to the power of x. All right, we're going to take a look at one more. And once again, we're using the same x values. All right. And our fourth problem, we're going to take a look at y equals 4 times 1/3 raised to the power of x plus 1. So here we're going to have a big combo of everything that we've done. For this one, I'm going to start at the bottom. So I'm going to start when x is 2. So we get y equals 4 times 1/3 raised to the power of 2 plus 1. So this will equal 4 times 1/3 raised to the power of 3. All right, so we have to set up like that in order to complete our problem. So we have 4 times 1 cubed is 1 over 3 cubed is 9. So 4, think of it as 4 over 1 times 1 over 9. 4 times 1 is 4. 1 times 9 is 9. So we get a y value of 4/9. When x is 1, we get y equals 4 times 1/3 to the power of 1 plus 1, which equals 4 times 1/3 raised to the power of 2. And I realized a mistake here. 3 to the power of 3 is not 9, it's 27. So I'll be over 27. Here we'll get 4 times 1 over 9. 1 squared is 1, 3 squared is 9, 3 cubed is 27. Pardon my mistake. So here, when x is 1, we get a y value of 4/9. When x is 0, we get y equals 4 times 1/3 raised to the power of 0 plus 1. So that equals 4 times 1/3 raised to the power of 1. 1/3 raised to the power of 1 is 1/3. So we have 4 times 1/3. 4 times 1 is 4 over 1 times 3 is 3. And then we have our negative x values, which they actually won't be too ugly, especially for the first one, because they're going to cancel out to 0. For the first one, so we have y equals 4 times 1/3, substituting in a -1 in for x. So we get -1 plus 1, which equals 4 times 1/3 raised to the power of 0. Once again, any value except 0 raised to the power of 0 is 1. So this will equal 4 times 1. So when x is -1, our y value is 4. And then we have the x value of -2. So we get y equals 4 times 1/3 raised to the power of -2 plus 1, which will equal 4 times 1/3 raised to the power of -1. Now for this expression, I'm going to work this out a little bit more just so we can see this property again. We have 1 raised to the power of -1 over 3 raised to the power of -1. And we raise both numerator and denominator to the power of -1. And using our law of negative exponents, we'll rewrite this expression as 4 over 3 to the power of 1 over 1 to the power of 1. So this equals 4 times 3, which equals 12. So when x is -2, y is 12. Hope you have a great evening, and I will see you tomorrow.